Okay, here we go. Chapter 13, video 4, and we're almost done. Two more things to go over. Hydrogen fuel cells, converting hydrogen into energy. Very neat idea. A battery is a fuel cell. It's just not a hydrogen fuel cell. There's just a reaction going on that's allowing electricity to be generated through acids. So, in a hydrogen fuel cell, we take hydrogen into a thing. It basically passes through a membrane, or protons are passed through the membrane. It reacts with water. It creates an electricity and it generates water. So the only thing coming out of a hydrogen fuel cell car is water. So that's good. And it creates electricity. The problem with hydrogen fuel cell cars, and there used to be some around and they've pretty much all disappeared, is getting hydrogen fuel can be very expensive. It's a very expensive and very energy consuming process to generate it. So that can be a problem. Because if I'm, again, putting $10 of energy in to only get energy worth $10 out, then why am I doing it in the first place? Why didn't I use the fossil fuels I was using to make the energy in the first place? So we always have to be concerned there. The other thing is it has to be a high pressure gas. So it has to be a very specific type of system. You can't just go fill up at the gas station. It has to be a locking system, so literally it locks on, it pressurizes the gas in your tank, that kind of thing. It can't leak. You can't just open your tank, it would all escape. It's a gas kind of thing, and it has to be under pressure. So there's special systems that go with that. We can't use our current infrastructure. If we were to go to a biofuel for our cars, then we can use the same infrastructure we have. We can use the same gas stations, but rather than gasoline coming out of it, it would just be ethanol. So that all stays the same. So hydrogen fuel would require a lot of infrastructure changes and some serious changes to cars and stuff like this. This is not just an easy adjustment. Again, hydrogen takes a very, very long lot of energy to create. It's not an easy thing to create. Usually we get it by actually separating water. So you're using energy to separate water to get the hydrogen to then put it back in the car to let it go back to water and release that energy. So again, it's not the most efficient thing. Fuel cells are expensive. The whole infrastructure would have to be changed. It's probably not the most feasible method of future energy for our cars out there. Sorry, I'm yawning. And again, most of the hydrogen is used producing fossil fuels, so why didn't we just use the fossil fuels in the first place? We can't go and use high fossil fuels to make the sustainable energy. That just doesn't work. It just does not equate. So if you were trying to convert to a hydrogen economy, using hydrogen in all your cars, your power plants, that kind of thing, again, it's possible. It's going to take a lot of conversion. Kind of thing. It's not a big it's a huge thing, and again, like, the infrastructure has to be there, so changing to hydrogen fueling stations is extremely expensive. $1 million for every single one. That's huge. So it's a very high cost system. You have to be able to make sure you can truly produce all that hydrogen gas you need very efficiently in order to make that cost efficient and worth it. So, advantages and disadvantages. There's lots of hydrogen. It's plentiful in water, but you have to break it apart. That's not good. Very low environmental impact. There's no pollution. It creates water. How bad is that? No CO2 emissions at all. It only creates water. It is a good substitute. It stores... It's easier to store than electricity. It's safer than gasoline or natural gas. It's non-toxic. It's efficient. I mean, all those things are great, but the disadvantages are huge. It's not found in nature, so we have to make it, which requires a lot of energy. It can often have what we call a negative net energy. In other words, we put more energy into making the hydrogen gas than we can get out of the hydrogen gas. If I have to put $12 into making it, but only get $10 out of it, kind of thing, or like energy-wise, if I put 2,000 joules into making hydrogen gas, but there's only 1,200 joules in the hydrogen gas, that's a net negative energy, and that's not good. That will never be efficient, kind of thing. So it's again, you made dinner for $12 and sold it for 10. You're losing money. Why'd you do that? That's not economically feasible or good. A lot of times there's CO2 emissions because we use fossil fuels to make the hydrogen fuel, so that's not good. It can be very costly. Honestly, it's not considered to be probably a long-term energy resource and would be phased out pretty rapidly, so it's not really worth the cost of converting it. The hydrogen fuel cars have a short driving range, so you're not going to get, most cars you can go 600 miles, 300 miles before you need gas, depending on the size of your tank, 3, 6, kind of thing. This, it's going to be less, 200 and you got to fill up, kind of thing. Right now we have no fuel distribution system to get this around, and then if we have excessive leaks, that can harm the ozone layer in the atmosphere. So it's just not feasible because hydrogen is difficult to get. If hydrogen was easy to get, it would be feasible. Producing electricity from the water cycle. Okay. There is a lot of things we can do with the ocean to create electricity. Of course, putting turbines in areas that have lots of waves and tides and that kind of thing. We can also use temperature difference. This is called OTEC. Ocean thermal something, I can't remember. Hopefully it's in the PowerPoint. But these are all ways we could use energy. And here's some examples. You could create basically a little dam. You wouldn't stop the flow. But this would cause, you would take an area that usually is wide and kind of condense it down so all your tidal water has to go through a narrower area, so it has to go faster. And it would spin these turbines. This is another type of turbine here. It kind of looks like one of those, a push mower kind of thing. You put it in, and as long as the water's moving fast enough, it'll turn this and create electricity. Anything that can be turned by moving water can make electricity. Voila! Which is, anything that turns can make electricity, which is how your hybrid cars do it, because things turn. And here, another one, you stick them under here. But again, the water has to move fast enough to turn the turbine fast enough to make it efficient. These don't necessarily take a lot of space. They don't necessarily harm any animals or anything like that. Pretty nifty idea. Maintenance can be a little difficult because they're down at the bottom of the ocean, but usually they're not very deep. 50 feet, 100 feet kind of thing. They're not usually really, really deep. Okay, so here's, kind of a setup. The fact is, what we need to realize, that in the future, when we try to move away from your fossil fuels and nuclear, not that we necessarily need to move away from nuclear yet, we're going to have a combination of energies. We cannot do it all with one. Your solar, your wind, your hydroelectric, those things, they're not 100% reliable, or they're not in every location. So we are going to need, a variety of energy sources to actually maintain us year-round for years to come. So it's all about combination, coming up with the right combination to provide it. And we'll do a project on that. Okay, so here's a final thing, going through the different types of energies. They're good, they're bad, they're other. This is from your book. Make sure you go through this. If you have any questions about it, please let me know. You should know at least 3 advantages and 3 disadvantages for pretty much all of these. Some of them you can group together, like the biomasses you can group and the biofuels you can group together. And then the others you should know pretty much the different advantages and disadvantages and kind of thing. So let me know if you have any questions. Other than that, we've wrapped this up, and time to wrap up energy and head on down to pollution. I will see you guys at school. Bye.